The second basic type of proportion is inverse or reciprocal proportion. Here are some examples using different ways to solve such type. Welcome to Mathematics of Engineering. Before checking some examples, let's review what inverse proportion is. This is the type where the quantities involved contain opposite trends. With quantities x and y, their relationship can be said as inversely proportional if x increases but y decreases or vice versa. There are two ways of solving inverse proportions. We work on the first example using the constant k. The problem states, 2 workers paint a fence in 9 hours. How long would it take 6 workers to paint the same fence? There are two quantities involved in the example. We assign x for the first quantity, the number of workers. The second quantity is the number of hours spent, and we assign y for this. Analyzing the situation, we can say that more workers painting the fence will finish the job earlier, so the quantities are inversely related. That is, y is inversely proportional to x. This is then transformed into equality by integrating k in the equation. When there are 2 workers, the hours to complete the job is 9. Place these values in the equation for k. So we have k as 2 times 9, or that is 18. So the relative equation for the situation is y as equal to 18 over x. For the second case, add the number of workers to 6, so the hours to finish the job would be shorter. This is computed using the equation. That is, y is 18 over 6, which gives 3 hours. Let's solve the same example by using the inverse method. How do we interpret the proportion? In inverse proportion, we place the cases horizontally. For the first case, 2 workers can complete the job in 9 hours. The second case would be written similarly when 6 workers will be working. Take note that for each ratio, there should be the same units. For the example, one ratio has workers and the other would be hours of the 2 cases. After arranging the terms, reciprocate one ratio. You can flip the first ratio or the second. For this instance, we will flip the second ratio and get x over 9. Now, through cross multiplication, we get 6x as 2 times 9, which can be simplified as 18. Divide both terms by 6 and get x as 3 hours. Let's work on the second example by using k. If 35 men can dig the foundation of a building in 8 days, in how many days can 20 men dig the same volume of foundation? Start by assigning variables for quantities. Let's say x is the number of men and y the number of days. When considering work processes, the more hands on the project, the shorter time spent. So y is inversely proportional to x. That is, y as equal to k over x. From the first case, when x is 35, y is 8. We use these details to solve for the constant k, which is the product of x and y. K is equal to 35 times 8, which results to 280. Thus, the working equation for this example is y as equal to 280 over x. For the second case, x is given as 20 and we determine y. Y is then 280 over 20, which gives y as 14 days. With the inverse method, we place the given parameters in proportion. The first case has 35 men is to 8 days. These are placed in the numerators. The second case states that 20 men work for X number of days. We then flip one ratio. That would make 35 over 20 as equal to X over 8. Through cross multiplication, we get 20x as equal to 8 times 35. That is simplified as 20x, which is equal to 280. Isolate x by dividing everything by 20, then get x as 14 days. For example 3, using the constant k, a fort had provisions for 300 men for 90 days. After 20 days, 50 men left the fort. How long would the food last at the same rate? Assign variables for quantities and let x be the number of men, y the number of days. With the inverse proportion of the situation, we use y as equal to k over x. Now let's analyze the premise. The first detail says that a fort has 300 men, with a provision for 90 days. At the end of 20 days, there are 50 men who left the fort. With the original situation, on the 20th day, there are still 300 men who have provision for 70 days more. This is where we are to take the equation, as after this instance, there will already be a different case ahead. So with k as the product of x and y, we get k as 300 times 70, which gives 21,000. The working equation then is y as equal to 21,000 over x. For the second case, x is then taken as the original number of 300 men less the 50 who left, having 250 men remaining. With the same rate of consumption, their provisions then computed to last as 21,000 over 250, and that is 84 days. Let's solve the same using the inverse method. The proportion will start on the 20th day, that is, 300 men for 70 days. This is the first case. Then, the succeeding case calls for 250 men. Flip one ratio and get 300 over 250 as equal to x over 70. Using cross multiplication, get 250x as equal to 70 times 300. This is simplified as 250x equal to 21,000. Divide everything by 250 and get x as 84 days. Let's have example 4 using k again. Here is the problem. 6 builders can build 10 houses in 30 months. How long will it take 18 builders to build the same number of houses? Let's say x is the number of men, and y the number of months to complete 10 buildings. With inverse proportion, y is equal to k over x. From the first case, the number of men constructing 10 houses is 6, and it takes them 30 months to complete the job. K is equal to the product of x and y. So k is 6 times 30, which is 180. The working equation is then derived as y as equal to 180 over x. For the second case, it was proposed to employ 18 builders. So we place 18 as x in the equation. That makes y as 180 over 18, which makes y as 10 months. Using the inverse method, the quantities in the first case are placed in the numerator. Those are 6 builders working for 30 months. The second case has 18 builders for x months. Reciprocate one ratio and have 6 over 18 as x over 30. Then by cross multiplication, we get 18x as 6 times 30, simplified as 180. Divide both terms by 18 and have y as 10 months.